everyone. For this video, we'll be discussing February-March 2025, the paper of Probability Statistics 2, which is the paper 6.2. Right, so let's have a look for our very first question. Okay, so for the first question here, we are given the random variable x and also the y. They are independent, okay, and both of them are normally distributed. So they want you to find the probability for x minus y smaller than 15. And basically x minus y is the linear combination of the variable. So to find the linear combination of variable, because x is normal, right? Y is also normal distributed. So the linear combination of any normal distribution random variable, they will be also normal. Alright, so the very first step is we need to find out the mean of this random variable first. So I'm having ex minus y, where it can be written as ex minus ey. That means the mean x minus mean y. So what is the mean x? You'll be getting this from the value given, which is 44. And also the mean for the y is actually 30, right? So you're having 44 minus 30, and therefore you get 14. This is the mean for x minus y. And after that, we want to calculate the variance for x minus y. Okay, so what's the value for variance x minus y? So it will be variance x plus variance y. So you have to take note that when you are having the minus in the variance, right, and you want to expand it, it is always a positive one because our final answer for variance must be always positive. So you have to make sure that the negative here, don't write it as negative, yeah? You have to make sure that it's always a positive. So what's the meaning for, what's the value for the variance x? It is 16. What's the value for the variance y? It is a 9. So by right, you are having 25 here. And like what I told you earlier, if the x is normally distributed, y is also normally distributed, then x minus y, which is a linear combination, will be also normally distributed. Oh, sorry. So I have to write in this way. So x minus y is also normally distributed with the mean 14 and also the variance 25. Okay. Then after that, how are we going to find the probability for x minus y smaller than 15? Okay, so since we know that the x minus y is normally distributed, so to find the probability, I have to change it become z. I have to standardize it become z because it is normally distributed, right? Okay, so to find the probability, like what we learned earlier, any normal distribution or normal random variable, if you want to find the probability, definitely you have to standardize it. So 15 is the value of x minus y. Then how should I standardize it? I have to minus the mean divided by the standard deviation, so divided by square root 25. So square root 25 is a 5, okay? So divided by standard deviation. Then from here, you'll get a value z smaller than 0.2. Okay, so let's find out this probability from the normal distribution table. So let's have a look for the table here. Where's the 0.2? So 0.2 is this one. So we're looking for 0.20. Okay, so the probability value should be 5793. Alright, so we go back. So it will be equals to 0.5793. Or if you want, please correct it to 3 significant figure, which is 0.579. Alright, so this is how we solve the first question. Alright, so let's have a look for question number 2. So we are given some time, yeah? The researcher records the time in T seconds taken by the adult to complete the questionnaire. So there are 60 adults who completed the questionnaire. These are summarized as follows. So you're having the sample size, which is 60. Then the total time taken is 3678 seconds. Then the summation of T squared, the time square, will be this value. So first, they want you to find the unbiased estimate of ET, the expected value of the T, and show that the unbiased estimate of the variance T is 14.44. So the keyword is unbiased estimation for the mean and also unbiased estimated value for the variance. Alright, so what is the formula that we can use to find out the unbiased estimated value for mean and variance? So to estimate the value of the mean, the general formula is summation of x divided by n, or summation of t divided by n in our case here. Alright, Then the estimation value for the variance will be 1 over n minus 1 summation of t squared minus the summation of t squared divided by n. So this is the formula for the unbiased estimated value for the mean and also the unbiased estimated value for the variance. Okay, so you might say that, oh, I forget or I can't remember the formula here, right? So no need to worry about it because the formula is provided in the formula booklet where you look for the probability and statistics part. Then you scroll down and looking for the unbiased estimators. So these two are here. All right, so if just in case, if you can't remember, at least you can still figure it out from the formula booklet, yeah? Okay, so let's come back to our formula here, into our question here. So to get the unbiased estimated mean, okay, so I just directly try to write out the formula here. It will be summation of t, which is 3678 divided by 60. It is a straightforward question, right? So by right, you should have 61.3. Right, so this is what we have. And after that, to get the unbiased estimated variance, okay, so it should be 1 over n. So 1 over n minus 1, sorry. So it will be 59. Then what's the summation of t squared? It will be 226,313.36 minus the summation of t, so 3678, you square it, divided by the n, divided by 60. Okay, and just press calculator and try to get the value. So if you press calculator, I think you'll get a fraction like this, 361 over 25. And if you correct it to the decimal number, right, change it become the decimal number, by right, you should be having 14.44, which is the value that they want us to show. Okay, so this is what we have for our part A. So you just apply it according to the formula. That's it. It is a very straightforward question. But of course, the keyword is unbiased estimate, right? Okay, so let's have a look for part B. For part B, in the past, they are saying that the population mean time was this one. So this is the record of the population mean time. And now they want us to test, highlight the keyword test. So this is actually a hypothesis test question. Okay, so test at the 2% significance level, whether the population mean time for this year is less than, highlight the keyword less than. Okay, so this less than basically will give you a symbol of less than like this. So it actually helps us to form the alternative hypothesis. Okay, so let us start the test, yeah? So first step, we have to write out the null and also the alternative hypothesis, and we are going to test the population mean. So the mu is equals to 62.4 seconds. And what is the alternative hypothesis? This is what they want us to test. Therefore, it should be mu smaller than 62.4 seconds. So this is our first step. Okay, then second step, we need to, it depends on you whether you want to use the critical value approach or you want to use the p-value approach. Yeah? So for me, I will use the critical value approach. Maybe at first you need to know what is the distribution for this question first, or when you want to run this test, what is the distribution first. Because I know that I'm having the big sample size. Okay, so the sample size is more than 30. And we are going to test on the population mean. Therefore, what we are going to do is like you need to know lah, okay, when we test for population mean and some more the sample size is large, so we know that our test statistic, which is a sampling distribution, will be also normally distributed. Okay, all right, so if I know that my sampling distribution is normal distributed, then you can either use the p-value approach or you can use the critical value approach. All right, yeah, so this is how you actually decide what is the distribution or what's the step that you should use. Okay, so if I want to use the critical value approach, then what I do is that I try to draw a normal graph, and then because I know that my alternative hypothesis is smaller than, right, it is a one-tailed test on the left, therefore I have to put my rejection region on the left as well. So I have only one side of rejection region, which is this one, and this particular value is 2%, so it will be 0.02, and this is actually 9%, 98%, which is 0.98. All right, so I'm interested to find out this value. This value will be the critical value. This is actually our critical value. So how to find the critical value? You need to find out from the normal distribution table in the reverse way, because they have give you the probability, but you want to find out the value of the z. So we are looking for 0.98, yeah, because the 0.02, right, the probability doesn't appear in our probability part here. So for this part, we should be looking for 0.98. So let's scroll down. Let's have a look where's our 0.98. So 0.98, find the value closest to 0.98. I think it's this one. 0.798, 9798. Then you have to add the 2, right? So if you want to add the 2, it can be either these two value, either one of these two value. Then you read out the value. So if you try to read the value, it should be 2.0. Then read out the value to the top here, 2.05. Then followed by these two digits, either it is a 4 or the 5. Okay, so if you read the value directly here, this is what you can see. So from here you can get 2.054. It is okay also if you use 2.055. Because no matter which one are you using, right, you actually add the 2 at the last digit, correct or not, to make it become 0.98. So these two are the value that is accepted. So let's continue further in our solution here. So I want to put this as a value. So 2.054. But you should aware that in our normal distribution table, right, the center line here is a 0 for standard normal distribution. So this particular value, which is before the 0, should be a negative value. So you directly write out negative 2.054. Of course, if you want to write negative 2.055 also can. They are still accepted. Okay, so next step, after I found the critical value, I want to calculate the test statistic. I'm using sample mean, sampling distribution, okay, as our test statistic. So Z, the test statistic Z is equals to sample mean minus the population mean divided by sigma over square root n. Okay, so let's have a look for the value carefully. Sample mean, what is the value of the sample mean? So in the first part, right, the mean that we calculate here is a sample. All these are the sample. So to calculate the sample mean, you take 3678 divided by 60. This is the sample mean, yeah? So just now, we use the sample mean to estimate the population mean, right? So the value is 61.3. So let's continue further. You should be having 61.3. What is the population mean all the while? So the population mean is actually 62.4. And this is what we want to test, right? Then divided by the population standard deviation. In this question, you can see that they didn't give us any population standard deviation, but just now in part A, we have used the sample to estimate the population variance. So you should know that this value is actually the population variance. Okay? And now I want to apply this value and make it become the standard deviation. So to make it become standard deviation, of course, you have to square root it. So square root of the population variance, then divided by the sample size 60. Okay? Then try to calculate the value carefully. By right, you should be having negative 2.242. Alright, yeah, so that's the third step. So now the fourth step is you need to make a decision. So how can we make a decision is, we want to put the test statistics into our region here. You need to know that the shaded region that I draw here is actually the rejection region. So the white color part will be the acceptance region, right? So put this value, negative 2.4242 into the diagram. I know that it should be located somewhere here because this red color line is negative 2.054. So this value, the negative 2.242 should be before. Okay, it should be before the negative 2.054. So you can see that this particular value of Z actually falls under the rejection region. Okay, so now we can make our decision here. Before you make a decision, please write out the statement, how you decide it. So you can say that the negative 2.242 is basically smaller than the critical value. So I better write out first. The test statistic, which is negative 2.242, is smaller than the critical value in this case, right? And the critical value is negative 2.054. But of course, for me personally, I always look at the diagram that I draw because I can see very clearly that the line here, the Z value, falls under the rejection region, which is shaded in what I show you here. Okay? Alright, so from here, I know that I should reject, it is under the rejection region, right? So you should reject the null hypothesis. So this is a decision. Then let's make a conclusion about our decision here. So if reject the null hypothesis means that we have enough proof or sufficient evidence to show that the mean has become less, right? Yeah, so please make a statement about in the context of the question. So you can see that, say that because you reject the null hypothesis, that means there is sufficient evidence, okay, to show that the population mean time for this year is less than the value 62.4 seconds. Okay, so this is a conclusion that is written in the context of the question. All right, so there are many ways for you to write out lah. So some students might say that, oh, there is insufficient evidence to show that the population mean time for the year is not less than 62.4. Also can. All right, so as long as you write a statement, yeah, about the conclusion that you have in the context of the question will do. Okay, so this is what you have for part 2. Part B. Then let's have a look for part C. So for part C, state with reason whether it is necessary to use the central limit theorem in your answer to part B. Okay, so in part B, right, I assume that my sampling distribution is normally distributed. So actually what is helping me to decide it, right? So like what I told you earlier, when the sample size is more than 30, okay, so regardless to the population distribution, I can assume that it is normally distributed. It is because of the central limit theorem actually. All right, so because they have carried out a lot of experiment before, so they realize that, oh, when your sample size is large enough, then in general, the sampling distribution looks normal. Okay, so that means for this conclusion here, we actually did apply the central limit theorem, yeah, so yes. So why do we apply the central limit theorem? It is because of the population distribution is unknown. Population distribution is unknown. We don't know what is the population distribution, but because of the sample size is large, therefore the sampling distribution is approximately normal. So this is stated by the central limit theorem. So in short, basically we are actually applying the central limit theorem to assume that our sampling distribution is normally distributed. All right, so this is how we solve question number 2. So we are now at question number 3. Okay, we are given a random variable x, right? And then the distribution is Poisson distributed with the mean 1.5. So find the probability of x greater equals to 3. Alright, so for your information, right, just to recall back a little bit, yeah, when you're having any Poisson distribution for the x, yeah, okay, so let's say you're having a lambda. So when we want to find the probability x equals to r, it should be e power negative lambda, lambda power r divided by r factorial. Okay, so this is generally what we should have here. Okay, right, so this is Poisson distribution, and then you need to aware that the value of the r can be 0, can be 1, can be 2, and so on until infinity, and all the value of r must be integer. Okay, so we know the formula here. If just in case if you're not able to remember the formula, you can still refer it from the formula booklet. It is actually provided in the formula booklet. Kindly looking for this where is it Poisson, this one. All right, so the formula is given here. Okay, so now to find the probability for x greater equals to 3, that means you need to start from x equals to 3, x equals to 4, x equals to 5, x equals to 6 until infinity, right? Because according to the definition here, your r can go up to infinity. So it is quite impossible for us to find out the probability like that. So what are you going to do is I have to take 1, that means the overall probability, which is equals to 1, then minus the value of the x that you don't want. So what's the probability of the value x that you don't want? It means that you don't want all the value of x which is smaller than 3. So in this case, it actually means that it included x equals to 0, x equals to 1, and also x equals to 2. So I'm having e negative lambda. So the lambda here is 1.5. Then lambda power 0 divided by 0 factorial for x equals to 0, right? So the value is a 1. Then followed by lambda power 1 divided by 1 factorial, which is the lambda, plus lambda power 2 divided by 2 factorial for the x equals to 2. Okay, so this is a slightly easier way for us to write out the formula so that you can press out the calculator easier. Right, so when you try to press calculator directly from here, by right, if you didn't do any careless mistake, it should be 0.191. Correct to 3 significant figure. Right, so this question is quite straightforward, right? So just apply the Poisson distribution formula for the probability. So let's have a look for part B. Okay, so for part B, we are now having 3 independent values of the x. So I can denote it by using x1, x2, and x3 lah. Okay, and then they are talking about the sum. Sum means that you want to add them together. Therefore, you're having x1 plus x2 plus x3. So they want us to find the probability so that this when I sum these 3 variables together, right, the value is between 3 until 5 inclusive. Okay, so before that, I actually need to figure out first, yeah, what is the distribution if I add the x1 plus x2 plus x3 together. So according to what we know, if let's say I'm having x is Poisson, and then the linear combination only for the summation x1 plus x2 plus x3 and so on, it is also Poisson distributed. Okay, so if I know that it is still Poisson distributed, first of all, I want to find out the mean for the variable x1 plus x2 and also plus x3. So I think you should know it should be 1.5 plus 1.5 plus 1.5. Okay, so you're having 4.5 here. So which means that your x1 plus x2 plus x3 will be still Poisson distributed with the mean 4.5 or the lambda 4.5. And now, according to this question, they want us to calculate the probability that the summation x1 plus x2 plus x3 is between 3 until 5 inclusive. So the keyword inclusive means that you have to include the equal sign. So it is between 3 until 5. What does it mean? It means that you need to find the value for x equals to 3, the summation, the sum of these 3 equals to 3, the sum of the 3x equals to 4, and also the sum of the 3x equals to 5. So if let's say the sum of all the 3x here equals to 3, then the formula is e negative lambda. The lambda now will become 4.5. Okay, then lambda power 3 divided by 3 factorial. This is for the sum of the x equals to 3. Then now, the sum of the x equals to 4, you're having e negative lambda, where I already factorize it out. Then I'm having 4.5 power 4 divided by 4 factorial. Then the next one will be the sum of the x equals to 5. So e negative lambda, where I already factorize it out, then I'm having lambda power 5 divided by 5 factorial. So this is basically how I apply the Poisson distribution formula here. And after that, if you didn't do any careless mistake pressing calculator, by right you have 0.529 as your final answer here, which is 3 significant figure. Alright, yeah, then let's continue to part C. So for part C, now I'm having the sum of a large number n. They are still talking about the sum, yeah? So the sum of a large number n of the value x is denoted by t. Use a suitable approximation. I think I need you to highlight the keyword approximation. It was found that this probability is this one, 0.0391. Find the value of the n. Okay, so now I just want you to have a look for the second part, yeah? So for second part, we are talking about the sum of the three independent value of x. So when you're having the sum of three independent value of x, so you're having 1.5 plus 1.5 plus 1.5. In short, that means you're having 3 times of 1.5, right? If you sum the three independent value of the x. So same thing happened here. Now I'm having a large number of n, and I want to add them together for the x. Okay, so by right, you should know that if I want to calculate the mean of the t, it will be n times of 1.5, because you have 1.5 plus 1.5 plus 1.5 for n times. N values of x, therefore it is 1.5 plus 1.5 for n times, right? So in short, you can write it become 1.5n. That means 1.5 times n. Just as just now one is 1.5 times 3, right? Because you're having the sum of 3x, so 1.5 times 3. So for part C, we are having 1.5 times n. And then like what I told you earlier, the sum of the Poisson distribution, right? It will be still Poisson distributed. Okay? Alright, and then now for this keyword, for this question, they did mention that the value of n is large. Okay, and also they already hint us to use the approximation. Okay, so that means so when I'm having 1.5 times n, the value, the lambda is large. So there's a type of approximation in our syllabus here. For Poisson, what can I change it? I can change become normal distribution. Do you still remember what is the condition to change it become normal distribution? When your lambda is large enough, which is more than 15. Okay, so for this question, although I don't know my lambda yet, but because they already hint us that the n is large, and then one more keyword is using the approximation, so we assume that this lambda is large enough so that I can change it become normal, right? So when you want to change become normal distribution, the mean is the first parameter, right? It is actually 1.5. You should know that the lambda in your Poisson is actually the mean. Then how about the variance? So again, you need to remember that the variance of the Poisson same as the mean. Therefore, when you want to change become normal distribution, it is also the 1.5n. Okay? Alright. So once you set up the question already, then now let us continue to figure out what's the value for the n. We need to start from the information given here. They already give us information to start with, which is t greater than 330. Alright, so I write out the information first. This is where we start. So t greater than 330 and the probability is 0.0391. Okay, so first step, we try to investigate what is the Poisson and what is the normal here. For Poisson, right, it is actually discrete random variable. And for normal, it is continuous random variable. Okay, so when you are changing a discrete to continuous random variable, right, what should you do? Because discrete, you are taking all the value for t, which is integer. Okay, then for normal, it is a continuous where you are taking all the range for the value. So you need to do some adjustment before you change discrete become normal become continuous random variable. So the process we call it as continuity correction, right? So you try to imagine, yeah, t greater than 330. So this one you no need to show in the exam, but you just need to imagine in your mind lah. So I'm having 330, 331, 332, 333. According to the equation here, right, t greater than 330. So does 330 included in your calculation? No, right? We actually should start from 331 because for this one, it is still Poisson distribution. So we start from t equals to 31, 331, then t equals to 332, and so on. Then you need to remember for continuity correction, the line that we use should be always before the area or the probability that we want to count. So from here, you can see that this particular value here is 330.5. So from here, I know that my continuity correction should be 330.5. And it is equals to 0.0391. Okay, so some students, they prefer to memorize the formula for continuity correction. Then for me, I just try to imagine all this in the mind. You no need to show in the solution. Okay, yeah. So next one. After you get the answer, after you complete the continuity correction, then now let's continue further. Since I already know that the t is now normal distributed, right? So to find the probability, you have to change it become z. How to change it become z? We call it as standardization. Standardization means that you have to minus the mean. Okay, then divided by standard deviation. So as a standard deviation here, it should be square root of 1.5n. And we know that when z greater than this value, it will be 0.0391. Alright, so the next step is, they already give you the probability, right? And you want to find the value of the z, right? So which means that now you have to use the table in the reverse way because the probability are all shown here. This is the probability. Outside layer here, the column here is the value of the z. So they give us probability. You need to find the value of the z. So we have to use the table in the reverse way. Looking for 0.0391, if you have a look here, there's no 0.0391 in this part, which is a probability. The smallest value start from 5. The smallest value start from 0.5. Okay, so what should we do? Therefore, I cannot use the 0.0391, but I can try to find out the complement or complementary area for the 0.0391. So let's say 0.0391 is this small area here. Okay, so I want to know what is the large area here. So for this large area here, you take 1 minus 0.0391, you should get 0.9609. Okay, then you should know lah, this is the value of z. Alright, you can find it out by using the table in the reverse way. But this value of z also denotes this one. Okay, z greater than this particular value, which is this one, then it is having the probability of 0.0391. Okay, so now instead of looking for 0.0391, we are looking for 0.9609. Okay, so go to the table, looking for 9609, yeah, scroll down a bit, 9609. So this is 9599, followed by 9608. Oh, so that means this is the closest value for 9609. And you can add a 1 at the back, right? So you try to read out the value that we get here, the value of z. So it should be, you're reading out 1.761. Okay, so by right, your value of z should be 1.761. Okay, so I hope that you are clear about this process, yeah? Okay, then continue further. I know that the z here will be equals to 1.761. That means when z smaller than 1.761, the area is 9609. If z greater than 1.761, it is equal to this probability. So it's very obvious that you're having 330.5 minus 1.5n divided by square root 0.5n equals to 0.0391. oh sorry, equals to the value of the z, which is the 1.761. Sorry, this is the value of z. Okay, so I hope that until this particular step, you're sure, okay, or you understand what am I doing here. Okay, so now to find the value for the n, you need to continue from here and then you solve for the n. Alright, so for your information, I have the process might be a bit tedious. Okay, I have tried out the method. I have tried out two methods. Alright, so I don't think that both is easy. It is quite tedious, but you just need to make sure that you have more patience on it when you are trying to solve it. Okay, alright, so for here, I will just show you one method that I'm using. Okay, so the other method I will suggest to you what are you going to do lah. Okay, but the final answer of course they will be the same one. Alright, okay, so let's continue to solve the equation from here. Okay, I know that this is the equation I want to solve. Okay, so first of all, I bring the denominator to the other side first. I think this step is pretty easy, right? Okay, then after that I want to move everything to one side. So I'm having 1.5n, okay, then plus 1.761 square root 1.5n, okay, then minus 330.5, then equals to 0. Okay, I don't know whether you're able to see it or not, but basically this is a quadratic form equation. Okay, so if you can't see clearly, then I write it again. I'm having square root 1.5 and then I square. So that means it will get back the 1.5 n, right? Then after that, I'm having 1.761 square root 1.5 n minus 330.5 equals to 0. Okay? Yeah. So I don't know whether you see it clearer or not now. It is actually a quadratic form equation, yeah? So you're having something square plus 1.761 something, then minus 330.5. Okay? If you still can't see it, then you can just try to assume that this square root 1.5 is a y. 1.5n is a y. Okay, so that means if you can see here, I change it become the y. So I'm having y squared plus 1.761y minus 330.5 equals to 0. So I think this is clear enough, right? It is actually a quadratic equation. Okay, yeah. So for me, I will still want to keep it as square root 1.5 n. Okay, so you try to imagine when you want to solve an equation, quadratic equation, by using the quadratic formula. Okay, so to find the y, so what is the formula that you have? So instead of y, I put it as square root 1.5 n. So what's the general formula? I want to use this one. In quadratic equation, right? So x equals to negative b plus minus square root b square minus 4ac divided by 2a. So I'm using the quadratic formula here. So same thing happened for this quadratic equation. So 1.5n, to solve it, I will have negative b. So negative b means negative 1.761 plus minus square root b square minus 4ac. 1.761 square minus 4. A is a 1 because the coefficient in front of the something square is a 1, right? 4a, then c is negative 330.5. And after that, I have to divide it by 2a. So divide by 2, and then a is a 1. Alright, so from these steps onwards, you can try to use calculator to help you and simplify the square root 1.5n into two sets of answer. The first one is 17.32046921. When you try to simplify the value from this equation, yeah, so you have two values here. One is 17.32 blah 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 blah. Another one is square root 1.5n is equals to negative 19.08096921. So of course, when you look at the value, it is like very tedious, right? It's very long, okay, and then it seems like so so worrying when you look at the solution here. All right, all the value that you get here. Okay, then now, this part, definitely I have to ignore the answer. Do you know why? It is because of when I'm having a positive. Here, there's nothing in front, but actually it means positive, yeah? So positive square root something, it is impossible for you to get a negative value. So we have to ignore this part. Then we continue to solve this one. I try to square both sides to get rid of the square root. Then I bring the 1.5 over. By right, the n that you get is a long value, 199.9991024. If I correct it to 3 significant figure, it should be actually 200. Okay, so n equals to 200 is the final answer for this question. Alright, so let's recall back again how I solve this formula. I'm trying to, after I get the value for z, I form this equation, right? And then you need to try to aware that this equation basically is a quadratic form equation. Then I solve it by using quadratic formula, then continue and get the n. To me, I think this method is slightly easier. Although the number looks very weird and also very long, okay? But to me, I think the step is not too hard to understand, okay? Alright, so there's another method, yeah? But I won't show you the detail here. I will just tell you another method which is correct also like this. It will be something like this. So some students, they will get this equation first. After that, they will square both sides. Okay, so when they square both sides, they will get rid of the square root. Okay, but when you want to square all this number, right, it is also very long one, the value. Okay, then after you square both sides, you're also getting a quadratic equation for the n. Then you still solve it by using the quadratic formula. Then by right, you have two answers for the n. If you are trying to solve it like this, I just show you here, yeah, but I won't show you the detail. So you have two value of n, which is 242.7349782. And then another one is n equals to 199.9991025. Okay? Yeah. So if let's say you are using the method of squaring both sides, right? You realize that final answer that you get got two value of n, and both of them look so logic because n equals to 200 is our answer, right? But what should I do with this value? This value also looks very logic. When you square both sides, your n is actually equals to 243, something like that. Alright, but how I know which one is the correct answer? So for your information, this is another part which is quite tedious one. For your information, when you square both sides, right, that means you might create one extra answer from squaring both sides. Okay, therefore, after you solve the whole thing and you get more than one answer, you always have to double check which one is the correct answer. So that means substitute n equals to this one into your equation originally, or this one, okay? Then you check and see whether is the equation true or false. So if you substitute 242 inside here, you will know that, you will see that the left-hand side value is not equals to the right-hand side value, which means that this is not the correct answer. Therefore, the only correct answer is this one. Okay, so for me personally, I will strongly suggest you just use this simple way of quadratic form equation. Instead of square both sides, you make the number longer. Okay, then eventually you still need to double check what is the correct answer. Okay, all right, yeah. So to me, I think this is a question that is a bit, I won't say that it is very, very hard, just that the way of solving will make actually students very nervous or maybe very worried because the numbers looks long, okay? And then you start thinking like, are you doing something wrong somewhere? All right, okay, so I hope that you understand this question. So this is how we solve the question number 3. All right, so we are now at question number 4. We are given a diagram and then it shows the probability density function of f of a real variable x. So the graph is a straight line. So I think it's quite clear that this is a straight line. And then it is starting from 0a, the point 0a until 2b. All right, where a and b are the positive constants. So I think this positive word is important. So elsewhere, fx equals to 0. So first question, it wants to show that b equals to 1 minus a. All right, so to prove that b equals to 1 minus a, let us have a look for some basic knowledge on the probability density function first. So it is a continuous random variable. Therefore, we actually need to know that the area under the graph should be always equals to 1. So that means that when you are having any probability density function, right, the area under the graph should be equals to 1. So to find out the area under the graph, there are two ways. You can either integrate the function, and you let it equals to 1, or you can use some general formula for the particular for the area of the particular shape. So like for this one, right, I think it's quite obvious that you are having the trapezium, right? It is a trapezium here. So we need to know that the area under the graph is always equals to 1. So what is the area of the trapezium? So you know that it is actually half the summation of the parallel line. So what is the parallel line here? So you're having this and also this one. All right, so what is this? This is A, the height, then this one is the B, right? Okay, so you should be having A plus B multiply with the base. So what is the base here? So the base is actually this one, where it is 2 units. So you multiply with 2 and you let it equals to 1. So I think from here, it is very, very easily you can get the result that they want us to prove. So B equals to 1 minus A. All right, yeah, so this is what you have for A, for A1. Okay, so let's look for part 2, A2. Given that the expected value is 1.2, find the value of A. All right, so how to find out the expected value of a continuous random variable? So just to remind, so just to recall, the expected value formula in general is you have to multiply the x with the function fx first, then only you start the integration. So this is how we get the expected value of the x. All right, so now our problem now is we actually don't know what is the function here. So we need to find the function first. So how to find the function? It is a straight line, right? This is a straight line. So to find out the function, we need to have the gradient and also the passing point. Okay, so I need to form the equation of the straight line. So I'm having 0 and A, and then I'm having 2 and B. So what is the gradient? Gradient, I put it as M. So gradient is y minus y1 divided by x minus x1. So you're having b minus a over b minus a over 2. All right, then after that, this is the gradient, right? And I have the passing point. So these two, you can use any of these two passing point and form the equation. So the general equation for the y is y equals to mx plus c. What do I get from this part? So y, I keep it as y. Gradient is b minus a over 2x, then plus c. C is basically the y-intercept. So if you have a look for the diagram here, the y-intercept is actually the value a. So you can directly put the c as a. So in short, this is my function for the particular graph provided on top. Okay, then now to calculate the mean, the expected value, of course, I have to apply this formula now, right? Okay, so now I'm integrating x multiply with the function that I find. I think I have to put where I think I have to put a square bracket here. This is m x plus c. Okay, so this is the expected value. X multiplied with the function f, and the limit that we put have to be the x value provided here. Our graph start at 0 and at 2. So the limit will be 0 until 2. And we know that this is the min, right? This is the EX. So this EX, we know that the value is actually 1.2 given in the question. Okay, then now before the integration, I have to multiply the x into the function, right? This one multiply to the first term, this one multiply to the second term. So you'll be having b minus a over 2 x squared plus ax, and it is equals to 1.2. All right, so now we can start the integration. So b minus a over 2 is a constant, so I just copy. I focus on the integration of x squared. So power plus 1 becomes 3 divided by the new power 3. Then for ax, you copy the constant a, x power 1. You want to integrate, it become power plus 1 become a 2 divided by the new power 2. Then substitute in the limit 2 and also 0, and you let it equals to 1.2. Okay, so next, we just try to substitute the limit in. So substitute the 2 inside, you're having 2 power 3, which is 8 over 3. 8 over 3 over 2, right? So you'll be having 8 over 6, or you can write become 4 over 3. Okay, so substitute 2 here. 2 square is a 4. 4 divided by 2, you get a 2. So you're having a 2a here. After that, you substitute 0, right? So no matter 0 is substitute into this particular term or this particular term, both will give you 0. So the whole thing is 0 here, then equals to 1.2. Alright, so for this question, because they are asking us to find out the value of a, in my solution here, I'm still seeing the b here. So I will want to get rid of the b. I substitute my result in first part, b, which is equals to 1 minus a, into my solution here. Okay, so b is 1 minus a, then minus a again, right? Okay, then plus 2a equals to 1.2. Yeah, so we just try to simplify this question, this equation. What should I have? 4 over 3, then 1 minus 2a, then plus 2a equals to 1.2. So you can try to move the 3 over. So you're having 4 minus 8a, 3 times 2 is a 6. Then 1 times 2, 1.2 times 3. So you should be having 3.6. Yeah, so negative 2a equals to negative 0.4. And therefore, you'll get your a equals to 0.82. Right, so this is how we actually get the answer for the value of a. Yeah, right, so let's continue further to the next part. So for the next part, they give us another random variable t with this probability density function. And the domain defined is from negative pi over 2 to positive pi over 2. All right, so what should I do here? They are asking for the value of the c, so that c is between, they already tell you the information where t from negative c to positive c it is equals to half. All right, yeah, so what should I have here is, you can try to use the information provided here to calculate the value of the c. But before that, maybe we can try to observe a little bit. Can we make the differentiation or integration, the integration easier first? All right, so when you're having cos t, right? Okay, when you're having cos t, you can imagine that your graph is actually something like this. Okay, and if I refer to the domain given from negative pi to positive pi, this is what I should have. Okay, from negative pi to positive pi. Okay, then according to this question, they said the probability of t between negative c to positive c, right? The answer is half. Negative c and positive c should be the same value. C and c should be same value, just that one is negative, one is positive. If you have a look for the diagram that we draw here, right? They are actually symmetrical at the center line or the y-axis. So from negative c to positive c also should be symmetrical, where maybe your negative c is here, your positive c is here, then this area is actually half. Okay, if I want to make my integration later slightly easier, maybe I want to use the idea that this black color part should be half of the half, which is 1 over 4. Okay, then this one is 1 over 4 also, so that you total up become half. And instead of using negative c to positive c, maybe I want to find the c by using a equation where it involves t between 0 until c is equals to 1 over 4. Okay, so again, maybe for those who want to use the negative c to positive c equals half to get the answer still can. But because I want to try to make my steps maybe looks easier and also without too much of simplification, without too much of the knowledge in trigo, right? So what I need to do is like, I will want to change it become the 0, start from 0 to c. Because if you start from 0, then later in your solution, right, you have only one c appear. You need to simplify another negative c with some extra knowledge or some basic knowledge in the trigo. Okay, so that's the reason why I start by using this equation instead of what they give us here. All right, because the 0 here, that means I already try to reduce the number of c appear in my solution later. Okay, all right. So let's continue from this part. Integrate from 0 until c, you get 1 over 4. So the probability is limit from 0 until c. The function is half cos t. So half cos t, and you let it equals to 1 over 4. Okay, right. So half is a constant, I'm taking it out. Integrate cos, what do you get? So integrate cos, you should have a sign. Then c and 0 equals to 1 over 4. Okay, then I want to substitute the c inside the sign. So I'm having sine c minus sine 0. The half here, I will bring it over, become multiply 2 on the right. So I'm having half. Okay, so sine 0 is a 0. Right, I think you all should know about it. Sine 0 is a 0. Therefore, sine c equals to half. How to get the c? So c, you have to take sine inverse half. All right, so sine inverse half, what do you get? So it is 30 degree. If let's say you try to use it in degree, yeah. So 30 degree, if you convert into radian, it should be pi over 6. All right, yeah. So this is how we solve the question number 4. Right, so we are now at question number 5. Okay, Amir believe that 20% of the students are in the college are left-handed, and then his friend believed that the true proportion is less than 20%. So I think maybe you need to highlight the keyword less than. This will be a keyword to help you and set up the alternative hypothesis. This less than, okay? All right, then after that, Amir plans to use binomial distribution, okay, to test the null hypothesis, given that this is your null and alternative hypothesis. So you can see that alternative hypothesis, right, actually related to the keyword that they tell us here. So less than means smaller than. Therefore, you can see alternative hypothesis is smaller than 0.2. He decided to choose 35 students at random. If 3 or fewer of these students are left-handed, Amir will reject his belief. Find the significance level of the test. Okay, so first of all, in this question, they already provide us with the null and also the alternative hypothesis. This is what we so far know. Null hypothesis is the p is equal to 0.20, where the alternative is p smaller than 0.20. So this is something provided by the question. At the same time also, they did tell us that he want to use binomial distribution. Alright, so we need to know that in this test, we are using binomial distribution to carry out the test. What is the total number of the students we have? So 35. So he chose 35. He used the sample of 35 students, and then he want to test whether the p is 0.20 or not. Okay, so this is so far what we have lah. All right, then if I try to read the last question before part A, if 3 or fewer of these students are left-handed, 3 or fewer of these students, that means the number of students is less than or equals to 3. So this is what we can get from this particular sentence, right? Amir will reject his belief. If let's say Amir reject his belief, what does it mean? Say? Okay, what does Amir believe? Amir believe that left-handed students are 20%. Okay, this is what Amir believe. So, and this Amir's belief, right, we are writing it in the null hypothesis, right, equals to 0.20, which is equals to 20%. So if let's say they say in the question, Amir will reject his belief, that means he belongs to null hypothesis. So reject his belief means reject the null hypothesis. If x is smaller or equals to 3. Okay, and then, of course, indirectly, this also tells us that the x smaller equals to 3 will be our rejection region. Alright, so the purpose of having this sentence, basically they are telling us what is the rejection region for this test. Okay, so we already know that x smaller equals to 3, then we reject the null hypothesis, which are Mills' belief. Okay, so the x smaller equals to 3 will be the rejection region. Then let us have a look what they want us to find. So they want us to find the significance level of the test. Alright, so we need to actually remember the definition. The significance level of a test is actually equals to type 1 error. Okay, right. So for this question, they want us to find the significance level. Therefore, we have to find the type 1 error first. Alright, so I already know the distribution, right? So we start from here. I know that significance level, significance level is equals to type 1 error. Okay, so what is the definition for type 1 error? Yeah. Okay, so you need to remember it. Okay, so the type 1 error will be reject the null hypothesis when the null hypothesis is true. Right, so what should I put if, let's say, I want to calculate the area which is reject the null hypothesis? So for rejection of the null hypothesis, we have to put in the rejection region where x is smaller equals to 3. Null hypothesis is true means that the p is equals to 0.2. Indirectly also, this one actually tells you that later when you want to do any calculation, you should be using x is binomial distributed 35 to 0.2. Okay, so we have to calculate the probability here. So by using binomial distribution, right, for x smaller equals to 3, what is the correct formula that we should include? So you should know that I have to start from x equals to 0, which is 35C0. Okay, so 0.2 power 0, 0.8 power 35. Then x equals to 1, so 35C1, 0.2 power 1, and 0.8 power 34. Then x equals to 2, so 35 plus 2, 35C2, 0.2 square, and then 0.8 power 33. And the next one will be 35C3, because they are saying x smaller equals to 3, right? So you have to include from x equals to 0, x equals to 1, x equals to 2, and also x equals to 3. So I think this is the last term that we have to calculate the probability. Okay, then by trying to use calculator and help us, you should get a long value actually. For what I get is this one. Then of course you have to correct it to 3 significant figure, which is this. Okay, and then if we try to read the question one more time, they're asking for the significance level. For significance level, right, we usually will put it into the percentage form. So 0.065, basically it should be 6.05%. So for me, this is what I will write it out. Okay, so this is how we solve the part A. Then let's have a look for the part B. For part B, they want you to state the probability of the type 1 error. Okay, so I already mentioned just now, right? The significance level basically is also equals to the type 1 error. So what is the type 1 error here? You just need to write out the answer just now directly, which is 0.0605. Okay. Yeah, so before I proceed to part C, right, I remembered something that I need to explain a little bit here. Some students will say, just now I'm using binomial distribution to calculate the probability, right? And then some students might say, why in this case I didn't change my binomial into normal distribution? Because the sample size is large. Okay, the n is greater equals to 30 because you have 35 here, right? So it actually fulfill the condition for changing binomial to normal. Because n is greater equals to 30, you take n times p, you get more than 5. Then n times q, you also more than 5. So why in this case I didn't change it become the normal distribution for the calculation of probability? Alright, so the main reason is because of in the question they did mention that he want to use binomial distribution to test the null hypothesis. So we will fully focus on this one. I will follow what they want. So for this question, they already mentioned very clearly that you have to use binomial. So I'm not going to consider how to change become normal at all. Alright, yeah, so that's the reason why I just keep it as binomial, but I didn't approximate it to the normal distribution. Okay, because of this. It is mentioned clearly in the question. Okay, so let's have a look for part C. Now they say that the true value of P is 0.05. Calculate the type 2 error. Alright, so what is the definition for type 2 error again? So you need to memorize a bit, yeah, because I don't think formula booklet is giving you the definition. So type 2 error is reject the null, accept the null hypothesis when the null hypothesis is false. Okay, so what is the symbol or anything I should put in the part of accept null hypothesis? So to accept null hypothesis, you have to put in acceptance region. Just now in first part, we know that x smaller equals to 3 is rejection region, right? This is a rejection region. So what is the acceptance region? It will be the complement of the x smaller equals to 3, which is x greater than 3. Okay, then null hypothesis is false. What does it mean by null hypothesis is false? That means on your P, originally your P is 0.2, right? This is a null hypothesis. When they say null hypothesis is false, that means P is no longer equals to 0.2. But if let's say P not equals to 0.2, I need one new value for the P so that I can calculate the probability here. Therefore, that's the reason why the question gives us a new value of P, which is 0.05. So here you have to use P equals to 0.05. Again, if you try to investigate the distribution here, it should be X binomial distributed. You are still having 35, but now your P will become 0.05. So please don't use 0.2 anymore in this calculation. Alright, then after that, let's calculate the probability. X greater than 3. Basically, it means that you can start from x equals to 4, x equals to 5, x equals to 6, until x equals to 35, which is quite impossible, right? So you'll take 1 minus x equals to 0, 1, 2, and 3. So let us start with x equals to 0 first. So x equals to 0 is 35c0, p power 0, q power 35. So this is x equals to 0. Then minus x equals to 1. Minus x equals to 2. And then x equals to 3. Okay, so after we get all the details here, then just press calculator and help us to get the answer. By right, your answer should be 0.0958. Correct to 3 significant figure. The original value is very long actually. Okay, so you can actually cut it short into the 3 significant figure, which is 0.0958. Alright, yeah, so this is how we solve question number 5. Alright, so we are now at question number 6, and this is the last question for this paper. Nikki is investigating the view of students at her school about the school sports facility. She plans to give a survey to the sample of students. So Nikki's friend said this survey about sport facilities, so you should choose a sample of students from the school sports team. So state with a reason whether you agree with Nikki's friend. Alright, so when you want to select any sample, right, to carry out a survey or whatsoever, you have to always make sure that the sample that you select is actually a random sample. So random sample means that it is random enough. That means you cannot specifically only selected a group of certain students, a certain group of students, or maybe a certain group that is with a special characteristic. Okay, so random means that you have to select, or maybe I should say in this way, random sample means that everyone in the population has an equal chance to be selected, but we are not going to focus only on one specific group, right? So for this one, for this question, basically, this is not a random sample because you can see that we only select the students from a certain group, which is the school sports teams. So by right, to carry out a random survey, right, you have to make sure that your sample is random enough. All right. So for me, I will say no. I will not agree with Nikki's friend's suggestion. It is because of the sample is not random enough. The sample is not random. Okay. Why it is not random? As it is only focused on sports students. So if let's say it is really random, then every student in the school will have an equal chance to be selected to carry out the survey. Alright, so that's the how we answer it. Okay, so always remember, yeah, when you want to form any sample to carry out the survey, then please make sure that the sample that you choose is a random sample. Right, then now let's have a look for part B. Now for part B, Nikki choose approximate 60 students. Alright, and after that she finds that 45 of these students think that the sports facilities are good. Calculate a 95% confidence interval, so highlight the keyword 95% confidence interval for the proportion of the students who think that the sports facilities are good. So the keyword will be confidence interval. And then we have two types of confidence interval. One is confidence interval for the mean. Another one is confidence interval for proportion. So do you still remember what is the general formula for the confidence interval formula for proportion? Yeah, I think a lot of students might forget about it because they always think that we only have one type of condition, the confidence interval, which is the mean. But actually we are having two, yeah? One is mean, another one is proportion. So the general formula for confidence interval for proportion is P minus Z, then square root PQ over N. Then the other one will be P plus Z, then square root PQ over N. So this is the general formula that we have, okay? All right, so now let's have a look for the question. They want us to calculate 95% confidence interval. So before that, maybe I try to calculate the P first. What's the proportion for the students who said the facility is good? So you're having 45 students say that they are good out of the 60 students, right? So if you try to press calculator for this, you know that your P should be 0.75. Alright, then now, if I want to calculate the 95% confidence interval, I just need to make sure that I put in all the value correctly. Alright, so according to the formula here, okay, this is P. P means 0.75 minus the value of the Z. So how to decide or determine the value of the Z? So you try to imagine, for a 95 confidence interval, right? They are saying that this center here is actually 95%, which is 0.95. Okay, so this is 0.95, and you need to know what is the Z here. Okay, then this is negative Z. But to put in the value of the Z, we are using the Z, okay, the positive one, right? Both of them are the same actually. Okay, so this negative Z means this one. The positive Z here means this one, right? So how can we decide the Z? Okay, then you need to refer back to your confidence interval here. The center is 95%, so you should know that this part is actually 0.05 divided by 2, so it is 0.025. Then this one is also the same, it will be 0.025. So that when you try to aware of it, the total area is always a 1. 0.025 plus 0.95 plus 0.025 is equals to 1. Okay? Alright. Then what to do next is, I want to calculate I want to find the value of the Z. So I want to see for this value of Z, right, what is the probability covered by Z smaller than Z. Z smaller than this value. So I highlight it or I draw it by using the blue color because Z is the line and I want to find out the area below the Z or before the Z. So to find the probability that Z smaller than this value, Z is equals to 0.975. You have to take 0.95 plus 0.025 because this Z cover this whole area on the left. Therefore, that's the reason why you use 0.975 but not 95. Okay, so look for the table. So again, probability is given, so you can find out the probability from here and go and figure out the Z. For me, I usually prefer to use the shortcut table here. Okay, and the probability that I'm looking for is 0.975, right? So this is the 0.975, and they already give us directly the value of the Z, which is much more convenient. Okay, so you can see that here the value of Z is 1.96. So sorry. So what you have is you have Z. Z is actually 1.96. Okay, then square root PQ over N. So you just substitute the value. P is 0.75, Q is 0.25, then divided by N. N will be 60. Then same thing happen for the upper limit, 0.75 plus Z is 1.96, square root PQ 0.75, 0.25 over N, which is 60. Then close bracket. Okay, so you just need to spend a little bit of concept and understand a little bit of concept on how to find the correct value for the Z. Okay, then after that, just need to make sure that you press the calculator correctly and don't do careless mistake. Again, you should be getting a very long value, but I will cut it short into 3 significant figure where it becomes 0.640 and also 0.860. All right, so this is how we get the value of the confidence interval. Okay, I think the the part that you need to be more cautious is this one. How to find the correct value of the Z. All right, so please spend a little bit of time to understand this one. All right, then let's continue further for part C. Okay, so for part C, now they say for a different investigation, Nikki used another sample to calculate a 99% confidence interval. And also she calculate X% confidence interval. Then they give you some relationship between the width, okay? The width of the 99% confidence interval double the width of the X% one. So calculate the value of the X. All right, so now before we start the calculation, I want you to focus on the width of the confidence interval first. What's the width of a confidence interval? You are taking upper limit minus the lower limit. If you take upper limit minus the lower limit, by right, you'll be having 2Z, then square root PQ over N. This is for the confidence interval for proportion. Of course, if let's say you are finding out the confidence interval for the mean, then you will become the width is 2Z, then sigma over square root N. But now we are calculating the confidence interval for proportion, right? So it should be something that is on top here. All right, okay? So now, if I have 99% confidence interval, I can try to calculate the width, right? But of course, I don't know what is the sample size because for here, they didn't say anything about the sample size anymore. But never mind, okay? So we try slowly and try to put in everything that I know first. Okay, so let's have a look for the 99% confidence interval. What is the width? So it will be 2 times Z. I need to know what is the Z, right? Then again, you need to recall back again. How is the graph look like? Okay, so 90%, sorry, 99% means that the center part here should be 0.99. Okay, so this center part here will be 0.99. Then where's the Z? This will be the value of the Z. This value will be negative Z. And what is the answer for this one, the area for this one? So you take 1 minus 0.99, then divided by 2. So you have 0.005. Then this one also the same, you're having 0.005. So that 0.99 plus 0.005 plus 0.005, you get the total area 1. Okay? Right, then now I want to find this value of Z. So again, To find the value of Z, I need the whole area below this Z. So what is the whole area here that I draw in blue color? So it should be 0.99 plus 0.005. So you're looking for 0.995, okay? All right, so looking for the probability of 0.995, again, we can go back to the shortcut formula. I think there's one value which is 0.995, this one. Okay, then the Z value is 2.576. Okay, so we are having 2.506 for the 576 for the Z. Then the square root PQ over N, I will get square root. P is 0.75, Q is 0.25, but too bad now I don't know what is the value of the N, so I just keep it like this first. This is the width for a 99% confidence interval. Okay, then now we are looking for the X confidence interval, X percent. Okay, so for X percent confidence interval, the width is what? It will be 2. What is the value of the Z? So this value of the Z, right, we actually need the value of the confidence level so that I can draw and see where's my Z. Okay, but for this question, X percent, I actually don't know what is the confidence level. So I also cannot find the Z yet. So I just keep it as Z first. Then I'm having square root PQ over N. Again, I don't know what is the value of N because it is not mentioned in this calculation here or in this question. Okay, then if you write out all the related formula already, right? Let's have a look at what they want us to find. They want us to find out the X, that means the percentage. Alright, so like what I told you just now, if you want to know what is the X, right? Before that, you have to know what is the value for the Z first. If you know the Z, then from there you can derive the value for the X. Okay, alright. So now, how to start? So again, they said width of the 99% confidence interval. So width of the 99% is this one, right? So I just put it here first. So 2 times 2.576 with the square root of 0.75, 0.25 over n. It is equals to what? So you have a look again. Width of the 99% confidence interval is double. Double means 2 times. Okay, 2 times of what? 2 times of the width of the X percent. So where's the width of the X percent? This one, right? So 2 times of the width of Z percent. So this is what we have. Okay? Can, Alright. Then now, from here, if I continue to solve this equation, by right, I will be able to get the value of Z. So let's have a look. So you see, this whole square root and this whole square root are the same, right? So I can cancel them off. These two and these two also, I can cancel them off. So from here, you can see that your Z is basically 2.576 divided by 2. And then your Z value should be equals to 1.288. Okay, all right, so now I successfully get the value of Z, so I have to do it in the reverse way, okay, in the opposite sequence so that I can find the Z percentage. So like what I told you earlier, our confidence interval, right, this inside here is the X percent. Okay, and after that, I know that this particular value of Z is equals to 1.288. All right. Okay, so before I can calculate the X, right, I need to calculate this area. I also need to calculate this area. Then I take 1 minus these two area. Then I'll get the X, correct or not? Yeah, so this is what I'm going to do now. Alright, so to get the X percentage, first step, I try to find this particular area first. So what is the area for Z greater than 1.288? Okay, so Z greater than 1.288 means that you have to take 1 minus, go for the table, looking for 1.288. So 1.28, then 8. So you're having 8997 plus 15. Okay, so trying to solve it or simplify it. Do you get 0 0.90? Oh, sorry, this is a 1. 9012. Okay, yeah. So here you go back. So for z smaller than 1.288, you are getting 0 0.9012. Okay, so you take 1 minus 0 0.9012, so you get 0 0.0988. Okay, so let's label the area. This area is 0 0.0988. You should know that in the confidence interval, right, they are actually symmetrical, okay, in the center. So this value of z will be a negative value, but same number, which is 1.288 negative. So which means that this area is also 0 0.0988. Yeah, so both areas here are 0 0.0988. So now can I calculate the x? So x is in the middle, right? Okay, so to calculate the x, I will need to take 1, that means the total area, minus 2 times of the 0 0.0988. Minus 2 times, right, left and right. Okay, then because they want the value in percentage, right? Because they are saying x percent. So that means you have to put a percentage here, but before you put a percentage, you have to multiply with 100. Without the multiply 100%, basically what you get is the probability, but they're asking for x percent. Alright, so let's try to get the value. So 1 minus 2 times of 0 0.0988, I get 8024. Then I multiply with 100%, so I have 80.24. Okay, then of course, we try to write out the value for x, correct to 3 significant figure. So by right, your answer should be 80.2. Alright, so some students might find that this is a bit confusing, but you always need to remember the confidence level of confidence interval, right? It is always is the value in the center, the area in the center. Alright, then it is symmetrical in the normal distribution. Therefore, these two areas by the side should be the same as well. So by doing it reverse way slowly, then you can actually get the answer for that confidence level. Alright, yeah. So this is the end of the video, and this is the end of the chapter the paper as well. So thank you very much for watching.